Welcome user to the new chapter Unsupervised Learning Algorithms. In this chapter we are going to see different types of unsupervised machine learning algorithms. We have already discussed what unsupervised learning is. In unsupervised learning, data doesn't have any output label, or we can say we don't predict anything from data. In this chapter we will cover k-means clustering, hierarchical clustering and principal component analysis. So let us begin with k-means clustering. Clustering is nothing but grouping of data based on similarities and properties. The data set shows same similarities and properties belongs to same group or cluster. It is also called as a non-hierarchical method of grouping objects together. The algorithm suits when dataset is huge. Over here you can see the steps we have to follow to perform k-means clustering. The very first step in the k-means is to choose the number of k clusters. The second step is to select k clusters and that will create initial centroid values. Then in step 3 we need to find Euclidean distance and assign each data point to the nearest centroid depending on Euclidean distance. In the next step, depending on latest grouping, assign new centroids. Repeat above steps until data points are assigned to the same clusters. Let us understand same steps by considering one simple dataset. First we will discuss mathematical approach and after that we will discuss with scatter visualization. Over here you can see simple dataset that I have made for beta analysis. According to the step 1, I am going to choose clusters. I have chosen k is equal to 2. In the next step we will pick any two entries from dataset and that would be our centroids for two clusters. Over here you can see I have chosen randomly two observations. K1 would be our first cluster and K2 would be our second cluster. The third step is to calculate distance from centroids to each dataset points, and calculated distance is nothing but Euclidean distance. I assume you all are familiar with Euclidean distance. Distance between cluster 1 and cluster 1 is obviously 0. Distance between cluster 1 and cluster 2 is calculated. You can see how it is calculated. Distance between cluster 2 and cluster 2 is also 0. Over here you can see tabular form. I have just added assignment to each dataset. Now consider next dataset and calculate Euclidean distance between data points. You can see how distance between K1 and 47 and 173 is calculated. And also you can see how distance between K2 and 47 and 173 is calculated. You can see calculated distance in tabular form. The Euclidean distance between dataset and cluster 1 is minimum, so I have assigned 1 to this dataset. Now update the centroid values. Now the next data point is 67 and 139. Again calculate Euclidean distance between these data points and updated centroids. You can see how distance between K1 and 67 and 139 is calculated. And also you can see how distance between K2 and 67 and 139 is calculated. You can see calculated distance in tabular form. The Euclidean distance between dataset and cluster K2 is minimum. So I have assigned 2 to this dataset. Now we don't have any new dataset. So we can conclude calculated centroids are the final centroids for this dataset. And if we see the assignment operators, we can see final table. We can now group data points based on the assigned assignments. And finally we have done grouping by using mathematical approach. Let us consider new analysis. Suppose we have random dataset and I have mapped those data points on the plot. By looking into scatter plot, we can easily say this one is our first cluster and this one is our second cluster. And also we can follow some steps to get cluster data. Now let us discuss the steps to create two clusters. Assume k is equal to 2. So select any two random points. I have chosen A1 and A2. Connect those points and find out middle point. And draw perpendicular to that line. Now you can see data is distributed. Now calculate centroids again. You can see updated centroids. Now again join these 2 points and draw perpendicular, and you can see we have done clustering by using simple geometrical condition. The data that we have used was very simple, but what if data is complex or have the multiple number of features? Over here you can see complex data. In k-means clustering, the first step is to decide number of clusters, but how we can choose optimal number of clusters? We can say for this new dataset plot we can make 3 or 4 groups. But to get optimal number of clusters, we use elbow method. In elbow method, we plot sum of squared error with respect to number of clusters. Over here, you can see the graph. As cluster number increases, sum of squared error will decrease. If we see graph carefully, it is looking like arm. So to get optimal number of clusters, find out elbow of this graph. Over here, you can see selected elbow and respective cluster would be the optimal value of k. Right here you can see mathematical form of sum of squared error, where k is number of cluster, xi is nothing but number of observations from selected clusters, ck is nothing but centroids of that selected cluster. So this is all about k-means clustering. This will end our video. In this video we have covered theory part of k-means clustering. In the next video we will see MATLAB implementation of k-means clustering. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our future. Happy MATLABing.